serves many roles at OSGi, including serving with me on the board of directors. But today he's wearing his Bosch hat and is going to talk to us a little bit about OSGi and EEBus. And with that, Kai.
All right. Good morning. I hope you can hear me. My voice is, a little bit, it's leaving me, let's say it this way, but I will try to keep up. So today I'm talking about, what we do with OSGi and EEBus, specifically for electric vehicle, charging stations, or with respect to electric vehicle charging station, heating systems, and home appliances. Before I start, let me allow me to shortly introduce you Bosch Software Innovations and also where I'm coming from. I'm basically from a product group within Bosch Software Innovations that's called ProSyst. ProSyst used to be an independent software company in Cologne, and Bosch acquired us in 2015, and we are basically now part of Bosch Software Innovations. Our roots are in Java, OSGi, with specific focus on embedded devices, all types of IoT gateways. We also do, for example, a device management software provisioning platform, also specifically for OSGi types of gateways. And so we provide now IoT solutions to many different domains. So maybe just to talk a little bit about the impact of software at Bosch. Yeah, so software is of very strategic value, and you may have seen what Bosch is doing within the IoT domain. So you probably notice that we're basically becoming more and more also a software company, right? So software plays a very crucial role, obviously, in the embedded devices. So Bosch is producing all kinds of, devices. So we are, worldwide #1 manufacturer of MEMS sensors. We do home appliances. We do tools. We do other kinds of things, or parts related to vehicles, electronic control units, and stuff like this. So software is here very crucial for us. Then the gateway part, it's also something that's why Bosch basically bought us. This is where OSGi comes into play. So here we do things like smart home gateways, PLCs or industrial controllers, and those type of things. Bosch is also working on its own IoT cloud and a so-called IoT suite, which is basically a set of microservices. There are a couple of colleagues that have presentations here, because this is driven also a lot in the open source community here at Eclipse. And then there is something that we do not, let's say, ourselves touch directly, but other parts within Bosch is the end user applications. So, as I said, so we we do various IoT solutions. So you see here things like Industry 4.0, smart heating, smart home. We do filters. We have solutions for tools to track them. Gardening robots. And also to track rail freight and stuff like this. And we also do a lot agriculture recently. So we have an OSGi-based gateway that is used in oyster farms, for example. So about this. So we are very active before, before Bosch bought us in the smart home domain. And so we basically do this since 2000, year 2000, you could say, and our software is already deployed in more than 1 million smart homes, and the number is actually growing a lot. Our approach here is to work wherever possible with open standards and also open source. So we are, we have been working in the OSGi Alliance, I think, also since 1999, and have also been contributing to various specifications, and also play a couple of I was the chair of the residential expert group, for example, where we did a couple of smart home specifications. Yeah, as I said, so this is just an overview of you know, industry standards that we are actively working or using, right? So EEBus is a topic for today, but there are lots of other technologies we need to consider. Just to give you an outline here. So before I jump into the EEBus, I want to give you a little bit of you know how we got here. Yeah. So why are we doing what we are doing? And so when I joined in 2001, ProSyst Software, it was still the independent company, right? So we were like 100 people. We were one of the few software vendors that were providing solutions for smart home or even connected vehicles back then. The term Internet of Things, that was not even invented in 2001. It started, I think, in 2005, 2006, when Kevin Ashton, started using it, and it was mainly in the scientific research community. And so we had a lot of cases where we were talking to potential customers, and an open platform was really scary to them, because they had issues like, what happens when something goes wrong? Who is liable? How does it work with warranty? So not even technical issues necessarily. We had them too, right? So Java was big and slow, but we have worked this out over time, right? And then another issue that we had in the past is that everybody was looking for a killer application. SMS was, the example they always used. I want to have something for smart home like SMS. Obviously, that nobody has found such a, a killer application, right? So, the companies basically didn't do the investments then, and we also had a couple of, let's say, product developments where companies actually stopped the launch of their products because it was, too risky for them. And in summary, you could say we were offering a solution to a problem that did not really exist. Yeah? So today, in 2017, it's all about platforms and ecosystems. Yeah? So it has really changed a lot. So we don't really have a problem anymore of, I need a killer application. The technology has advanced enough in order to provide, let's say, scalable solutions. So now we have other problems. So today, this is from IoT Analytics. It's a German research company. They say there are 450 IoT platforms on the market. And this, let's say, 90 more than they had in 2016. So it's kind of crazy, yeah? So it's really difficult for somebody to choose, the right platform for the right problem. Of course, this, it's like a mix of things, yeah? So this contains the, the gateway part, this contains the cloud part, the big data part, and all of it. But in the end, it's a wild mix of platforms. Then we have to deal with the fact that we now deal with many different domains. So energy is the focus of today and smart home, but there's also the industrial IoT, there's healthcare, there's the connected vehicles and so on. Then we need to deal with the fact that we have to integrate a wide range of devices. Yeah? This could be something like a simple temperature sensor, but can also be like a very complex machine in a factory. Device abstraction only takes a part away, or the part of the pain away. Yeah. So it doesn't solve the whole, let's say, issue, because it, at least in the case of OSGi, it's like this, that we can abstract devices from their protocols, but the semantics that describes a device, that we don't have yet, and that is something that the industry is currently working on. And then I think you see that the complexity is even increasing more. Yeah? So you see smart home is part of smart grid is part of smart city. Obviously, there will be no single vendor that provides a solution here. So that really makes the need for standards very clear. Yeah. Okay. So EEBus is an initiative that started as part of a research project. I believe in 2017 there was a research program called e-Energy, and they funded a couple of projects. One of them was called Smart Watts. There was a company called Kellendonk that started this initiative. So they have basically started developing technology in this project, but it has changed since then actually a lot. So there were some developments since then. So and EEBus basically has one goal. Yeah, they call it like the language for energy. So they want to have like a standardized way of exchanging messages between different building blocks within the smart home or in the building, or even to vehicles and so on. There is a website, eebus.org. They have both German and English versions, but currently it's more like a German-driven initiative that is also trying to work on making this internationally adopted. All right. So motivation, some of these motivations are basically the same to OSGi in a way. So there is a problem that you have separate control of isolated tasks the separate control of isolated tasks in smart home is limited. Yeah. Vendor neutral operation is also kind of limited. There's no way of allowing the combination of heat generation and room temperature control in a smart home. That has also changed a bit since a while, but that was a motivation back then, right? Then the efficiency, the possible increase in efficiency could not be realized, and we currently see, especially in Germany, a growing percentage of renewable energy sources. Yeah, so I don't know whether you're aware of it, but Germany kind of has, like we call it, Energiewende. This term basically, also made it, public internationally. Yeah, so this is really about the transition, yeah, from atomic power plants or nuclear power plants to renewable energy sources. That, of course, comes with a price, because the network or the grid is not designed to deal with so many different, let's say, producers, energy producers, if you want, or even consumers. So then, obviously, the availability of renewable energy sources is fluctuating. You cannot, count the whole day on the sun or on the wind, right? So you need to deal also with this basically. Yeah? So there's currently a new research program by the federal government that deals with exactly this problem. So how do I make my grid more intelligent? So how do I connect the wind farms basically to the other participants in the energy grid, even to the smart home? Yeah? And how can I basically forecast, when energy is coming from the renewable sources and when do I need to get energy from, power plants and so on. All right. So, yeah, this then. So who is behind EEBus? So EEBus is basically a non-profit organization. You see here the members. It's basically similar to OSGi Alliance. So there are a lot of companies that participate in defining the standards and that also start, adopting it in time. So you see here white good manufacturers. You see, vendors of solar panels, electric equipment providers, and so on. So it's really a broad range of members, even car manufacturers. I believe Volkswagen should be a member, and so on. So, all right. So then there is also, let's say, collaboration within the national and international standardization bodies. So they work with, a lot of associations in Germany that do real standards, right? They got support from the European Commission to, fund research projects in this area. and they also work with international standardization bodies to basically, you know, get broader adoption here. So this is basically what you know, comes out of EEBus. So we'll move now a little bit because I guess it's easier. So EEBus has basically 3 kind of specifications. So one is called the SHIP specification. SHIP stands for Smart Home IP, and it's like, you know, it's a protocol. Yeah, it's IP based. It uses MDNS for, you know, identification and discovery of devices, and it's TLS secured. And actually, there is a federal association about security in Germany, and they basically follow the principles of this association, which is like, you know, yeah, key here. Then we have the SPINE protocol. So the SPINE protocol basically defines a couple of things, like, you know, you have a header, you have you're binding the destinations list, so which devices or which, you know, building blocks within the in the building on the smart home you want to talk to. You can just subscribe to those, let's say, events, and there is, of course, which, as I said, you know, discovery mechanisms. And then they define resources. So they have several device types like heat pump, heating circuit, washer, power sequences, and so on. And they make also yeah, XSDs available that you can use to basically you know, implement them in your XML schemas and so on. So the specification was released in May 2016, so it's rather new. So it's version 1.0. The specs are publicly available. So you have to basically register, but you can get them, you know, you can download them without paying for it. And there is currently work on an update that, let's say, yeah, provides new features to implement e-mobility use cases. So that I expect this to happen in early 2018. So how do they do the specification, or how does the specification process works? So it's a little bit different than in OSGi. In OSGi, we have, you know, the requirements document where we define use cases, requirements, and so on, right? The problem domain, and then we go to the design. So here it's a bit more oriented on, let's say, the use cases, usage scenarios, right? So you define the usage scenarios, then you basically analyze what needs to be communicated for this, in order for this to happen, right? Then you make, or they make a mapping of the, you know, needed language elements, and then basically the result is, you know, a validation of, you know, the language elements they have defined. They do common vendor-neutral tests. They're also plug-fest. I will say something about this also later. And then you basically have a, you know, vendor-neutral solution working at home. So EEBus, let's say, as I said, is use case oriented, and the current, let's say, use case scenarios are around how to display information from various sources, to make allow for operations and to enable energy management, and the goal is to increase the total energy efficiency, to save energy costs, and to increase also the comfort at home. And so in our case, so what we do basically is, you know, we want to have a smart home gateway, OSGi-based smart home gateway that talks to the different yeah, devices at home. This is an overview just to get an impression. I will show a little bit of this during my presentation. So basically, there are use cases related to the grid, to white goods, to HVAC devices, and also to e-mobility. And as I said, so it's around display, configuration, and energy management. So this is just, again, a list of use cases they defined already in EEBus, and it's totally not related to OSGi. We just choose to implement them in our OSGi gateway. So there is you can monitor system functions of an HVAC system. You can monitor the heat pump power consumptions, monitoring of temperatures in the HVAC system, or even the monitoring of the electricity grid connection point, right? And again, SHIP is, I didn't mention this, maybe I should. SHIP is one protocol they defined themselves. It's an option, but not entirely, so it's not a requirement to use it. You can also use other protocols. So it works also with ZigBee and other protocols. So there are more use cases around how to display information around photovoltaic systems, home battery status, the car charging current, and so on. Monitoring the smart grid ready status. So we have, for example, I know Miele does this. They have so-called smart grid ready home appliances like the dishwasher and the washing machine, and you press a button that says, I'm ready. And then it waits basically for a signal from the outside world. This could be, from the utility. This could be from, I don't know, whatever service provider that tells him or the device, now, energy is, at the cheapest, or now, it fits in the, in the peak, you don't have a peak consumption problem in the network, for example, right? So there can be several use cases around this. So there is then, you can configure the system functions in your HVAC device, so you can, set it to different modes. You can configure the temperature, obviously, and so on. So this is for the room, as well as for the hot water temperature, for example. Okay, energy management, smart start. I basically already said this in the previous slide. Then there is direct control in order to increase the consumption or to the balanced load peaks. Then you have also an overload protection. That's basically something that makes a lot of sense for electric vehicles. So here the use case is basically you put your electric vehicle, you plug it in, and you want to make sure that the electricity in your home doesn't collapse, right? So, and you also want to make sure that the car is fully charged when you want to leave the home for for work, for example. And these are the kind of use cases they basically implement here. Then there are use cases around optimizations of self-consumption during the charging. Yeah, so you can limit the charging current in order to optimize the self-consumption of power generated by photovoltaic systems. You can have coordinated charging plan, even with a utility, for example, right? Then PlugFest. So EEBus has done so far 3 PlugFests, and I think they are very useful. And there are a lot of participants also. The first PlugFest was around, let's say, when they released the specification. So they had participants from white goods, from the HVAC vendors like Weiland, Wolf, SMA as photovoltaic energy management vendor, but also other vendors like Bosch, Diehl, Fraunhofer, Utility, MVB, and they basically, let's say, work use case oriented. Yeah, so they define use cases and they define who works between each other. Yeah, so I will explain this a little bit in more detail for the e-mobility use case, because that was the one where I participated. Then they had a PlugFest this year around HVAC devices. Here we had obviously the HVAC vendors. IBM was hosting this at the Watson IoT Center in Munich. And as I said, so there was this month a PlugFest around e-mobility, and here we were working, with Hager, SMA, Volkswagen, Mennekes, VDE, to basically, plug different components together. So how this worked in this case is, so Hager is using, for example, our OSGi framework in their energy management system, which you put on a DIN rail in your home. And then they were working against the charging station that was provided by Volkswagen, or against what Mennekes is doing. And they have a set of use cases they basically test against, and see if the message exchange between these participants works. And again, the use case is really, for example, protect or to avoid overloading and so on. Yeah, and VDE, that's a German organization, standardization organization for electrotechnic. What's electrotechnic in English? Anybody? All right, so something electronically, but I mean the old electronic stuff basically, right? So and they developed for the EEBus association a test environment. Yeah, so they have like all the let's say test cases for the different use cases. Okay, and this is basically what we did now at ProSyst. So we have implemented the SHIP protocol. I mentioned already it's based on MDNS. It follows the requirements of the German Federal Office for Information Security. This is what I was missing before. We have we call it Home Device Manager Adapter. So it's basically a protocol adapter into our framework. Then we implemented also SPINE, which provides which allows message exchange on a common data model and also enables semantic interoperability. As I said, this is not limited to SHIP, and we also implemented, we call it EEBus device exporter that allows mapping of EEBus devices to other communication protocols. And we support basically all kinds of use cases, also those from e-mobility that are still kind of in development. But basically it's close to final from what I hear. So this is how it looks in our framework. So as you know, ProSyst used to have all different protocols, especially with respect to smart home. So we have protocol adapters for all these protocols, and now even for EEBus SHIP. Then we basically have our device abstraction layer on top of it. And here is basically where we call this functional items, where the device, the data types are defined, where we make use of the SPINE XSDs. I don't want to bore you with all the other stuff, but so these are basically all OSGi standards that we implement here for discovering new devices. We have security, remote management over tier 69 or OMADM. We provide the capability to do software updates, obviously in the framework, and all the logging. Device abstraction is also based on the OSGi specs, and then we have some other stuff that we do on top of it. There's a so-called automation engine that we contributed to the Eclipse Smart Home project, and here you can define scenarios. So you can say, when the vehicle is charging, then turn down, for example, the heating device, just as an example, right? Then we have we call it history and statistics. I call it like a little bit of data analytics light. What we do here is basically we store information coming from the devices, and we can process it also locally. And then you have all kinds of APIs to do your apps, be it locally in the OSGi environment, or as an Android, iOS app, or maybe even a web app. So this is how it basically looks like end to end. Yeah. So you have here on this side all kinds of devices that talk EEBus or maybe even other protocols. They communicate basically to the gateway here. This is, let's say, let's assume this is a smart home gateway, and here on the other side, we may have an IoT cloud, whether it's Bosch or anybody else, doesn't matter. It can also be an on-premise management system. And here we basically use, also the standard mechanisms like from OMA tier 69 to be able to do device management, software provisioning. Yeah. So, and our stuff is also designed to run in different cloud environments. So, we are not bound to the Bosch IoT cloud. The remote manager is available on AWS. SAP, Leonardo, we are now working on Azure support and even IBM Bluemix. So in summary, we see a growing adoption from vendors of HVAC, white good appliances, smart home energy management systems, also electric vehicle car manufacturers. So there are several products already out there, especially from white goods and HVAC, yeah. And the other areas are, currently, developing, in my opinion, very well. Yeah, EEBus is enabling an increase in efficiency, yeah. So allowing you to use as much as possible safe-generated electricity for, charging your vehicle or to use it at home, right? It also helps to load, to reduce the load in the public networks. Also the charging process can be controlled by the utility, which is, let's say, very important to keep the grid, stable. And I mentioned this, EEBus also enables the overload protection, yeah. So when you, let's say, start your boiler, that, the electricity for the charging of the vehicle will be, limited. In my opinion, OSGi and EEBus are a natural fit. So both enable vendor-neutral interoperability in smart homes, but also for building automation. OSGi provides the ability to have, modularization of applications in your gateway. It provides all the capabilities around, device management, software provisioning, and so on. And EEBus basically provides a standardized way to talk to, let's say, or to exchange messages between different building blocks in the home. All right, this would be it from me for now.
Thank you, Kai. We have just a couple minutes, so we'll have time for one or two questions. Anybody have any questions?
Please. I mean, to be honest, I mean, right now it's really depending on our, device abstraction layer, right? So if you implement the standard OSGi device abstraction layer, I would expect you to be, able to use it as well. SHIP, yes. It's using IP, right? But again, so for exchanging messages, yeah, you have no dependency on the SHIP protocol. You could also have non-IP based protocols to exchange messages.
So what's the integration between smart home gateways like this one, which is secure and like connected to the grid, and more connected gateways? Is that a separate network, or are they like separate security spaces on the same gateway?
So I mean, right now the use cases or the customers that basically use at least our technology, they don't use it to combine those, let's say, two worlds. So it's really around, energy management, yeah, and probably in this case, I don't know about SMA, you also have a smart home system, right? How you do with this, but Hager really, is managing just the energy of the, exactly, yeah. In your case, I don't know.
So you're only combining the measurement management, but they are relevant for the billing.
Yeah. I mean, EEBus doesn't prevent you from doing it, right? But currently, as it is used, it's not really, you know, relevant. Yeah. All right.
We're at the end of our time. Thank you, guys.
Thank you.